Welcome to homework.
19.1. So we want to calculate the voltage across the terminals of the battery with an EMF of E and an internal resistance of R given up here for different load resistances connected to it. And so this dashed line represents the sort of physical battery, and then inside is the sort of ideal battery and then its internal resistance. And then we want to do this for two values of this load resistor here. So this is one of those things where you can do most of the math before you start putting in. You can do since you're just looking at two different values here, you do all the math algebraically before worrying about starting on a particular part of the problem. So the current through the circuit is going to be the EMF divided by the total resistance. And these resistors are in series, so it's just the sum of them. So the voltage here using Kirchhoff's law, we start going up by an E, the EMF, and then when we get here to the other terminal of the battery, we'll have lost a voltage of I times R. And so putting in what we have for I, we get E minus E, then our little r from here, over big R plus little r. And just sort of algebraically simplifying that, we get E times big R over big R plus little r. So now putting in 71 ohms, we get that the battery's terminal voltage will be 5.92 volts. And then if the resistor is instead 710 ohms, the terminal voltage for the battery will be 5.99 volts. And this is sort of what you would expect. As less current is going through this internal resistance here, the voltage drop across it decreases because of Ohm's law.